students, today we are going to start a new chapter, that is Taxonomy, introductory chapter. First, we need to understand the origin of the term zoology. That term originated from two Greek words. They are zoon and logos. Zoon means animal and logos means study. So, study of animals is zoology. Then we are coming to taxonomy. Under this heading, there are some terms we need to familiarize with. They are systematic. What is systematic? As the name implies, it is a systematic arrangement. Arrangement of what? Arrangement of properly identified and named organisms. What all organisms we named, we identified. We are arranging in a proper manner. That entire process is called systematic. Systematic arrangement of properly identified and named organisms. From where that term emerged, the Greek word systema. And identification. What is identification? Identification means if we happen to come across some a strange species first, and then we are identifying and identify up to its species level, then we can say that we identified that particular organism. There is a determination of its correct position in the plan of classification. The plan of classification, you have already studied in your first two classes. They say hierarchical system of classification there. So, when we finish, when we can identify a species, organism, what is a species, then we can say that we identify that organism. Then taxonomy. Taxonomy means that entire practices we follow for identifying that organism. So theory and practice of classifying organisms. That term is coined by D. Cantor in 1830. Then phylogeny. Phylogeny means it indicates a relationship. Relationship between what? Between ancestral relationship. If we come across one organism and how that organism relates with its ancestors, in how much, in what way it related to its ancestors. That finding, that understand is called phylogeny. And then phylogenetics is there. Phylogenetics means it is this field of biology concerned with identifying and then understanding the evolutionary relationship between many different kinds of life on Earth. Phylogenetics is also studying and understanding that evolutionary relationship. To understand and identify what? Evolutionary relationship between many different kinds of life. Life means many different kinds of organisms on the earth. That study of relationship, evolutionary relationship, is called phylogenetics. Next. Then in taxonomy, the practice of classifying organisms, there are several stages: alpha taxonomy, beta taxonomy, and gamma taxonomy. Alpha means when we have an organism, we identify its species, we characterized it, and we named it, and that process is called alpha taxonomy. And after that, we need to arrange that species into a natural system of lower and higher category. We need to say that it goes in such a phylum, and then it comes under that genus. In that way, that hierarchy, we need to explain what is this taxonomical position. that all deals in beta taxonomy. It's the arrangement of species into a natural system of lower and higher categories. Then gamma taxonomy means what? Gamma taxonomy means we are understanding into what extent, what are the differences exist within the same species, and also what is the evolutionary relationship between different species, not the same species, between different species. So first we are identifying, second we are arranging, and the last stage we are analyzing the variations within the species and also between the species.
Next is about the history of classification. Who is the father of biological classification? It's Aristotle. Okay, then we need to understand about his classification, his method of classification. He classify all the members, animals that are showing similar characteristics into one group called genera. Okay, and again he examined closely all the members included in this group and find which all members are more alike, more similar. And for example, he found that these two members share more common characteristics, and he put those members into another group, and that form a species. Species. Clear? It's P-E-C-I-E-S. Species. And the members that included in this level, they share common characteristics. This is the method followed by Aristotle. And according to him, animals are classified under two groups. They are blooded animals and bloodless animals. That type of classification is similar to the classification that is classifying animals into vertebrates and invertebrates. So we can go and understand about the blooded animals, which all categories, which all animals are included in this class category, blooded animal category. First one is viviparous quadrupeds. Viviparous quadrupeds, mammals also comes under that class. Then birds included in this genera, and then oviparous quadrupeds, that includes reptiles, amphibians. Then fishes are also included in this genera. Then whales came, but at that time Aristotle didn't know that whales are mammals. He didn't realize that fact that time. And the next group includes bloodless animals, and which all get included in that group: cephalopods, which includes octopus, then crustaceans, then came insects, then shelled animals like mollusk, echinoderms, and then lastly zoophytes. Zoophytes means plant like animals, and also example also given here, coral. Coral is an example for zoophytes. Okay, this is all about Aristotle's classification.
Then in his classification, he oftenly expressed a term, scala naturae. What is scala naturae? He thinks that organisms can be arranged on a scale. How we can arrange on that scale based on the increasing degree of complexity in structure based in morphological complexity. Okay. So, in the order of that increasing complexity, we can arrange organisms along a scale according to the perspective of Aristotle. That is called scale and aspect. Then some new advents came in the field of classification. That means some experts and scientists have understand that need to study the anatomy before doing this classification. Such type of work, such type of thinking starts from the later part of 16th century and the beginning of 17th century. And the first pioneer medical anatomists are Frederick Petrus, Severinus, William Harvey, etc. And also some other entomologists. Entomologists means the scientists who are studying insects. Entomologists and microscopists doing work with the microscope. They are also give so many contributions in developing a system of classification. Marcelo Marsighi and John Sameda. Then one more eminent person is John Ray. John Ray, he gives very valuable information, suggestions regarding the classification of plants in his book Historia Plantarum. And we are going to Linnaean taxonomy. Systema Naturae. Systema Naturae is his book. Whose book? The Carlos Linnaeus first book. It has so many editions. His first edition came by 1736. And Linnaeus is known as father of modern classification. What were the ideas of Linnaeus? He told that every species should have should have a name having two parts. Binomial system of naming should be there for every species. Binomial means two part means first half should indicate the genus of that species and second half should represent the typically the species. Species. Which species is the first half represents genus and second half represents the species. So every organism should have a name having two parts. It's a binomial nomenclature. And then after the advent of so many other modifications, trinomial nomenclature also developed. Trinomial means three parts will be there in the name of an organism. Three parts means first part of course is of genus, second half is of species, and the third means in some species, because of the difference in the habitat occupied by the same species, it stands for the development of some difference within the species. Difference within the species, and that difference leads to the emergence of subspecies. Means a different group within the same species. So the third part of the trinomial nomenclature name of an organism, that third part represents the subspecies of that organism. And that system is developed by Lamarck. Then Linnaean system of classification. Linnaean system of classification means it's the orderly arrangement of animals and plants under successive sets of groups called taxa. Means on considering each and every organism, first based on some characters he included in a big group, and from that big group, after considering few more common properties, taken down to a somewhat small group when compared with the first one. Then from that group, even considering more similar common characters, again confined to much smaller group, like that way. The hierarchy. Hierarchy means hierarchical means the top will be the bigger one, big group. As coming towards the down, it confined, it becomes precise, and finally ends up in the species of that organism. I will show you in the next slide. The classification. First is a big group domain, and from that consists of eukaryotes. Eukaryotes means it includes plants, animals, everything. Then from some characters, we know that animals and plants have distinct characters. So based on that difference, and animals are grouped under Animalia, that kingdom. From that and media based on some features, again some group, some collection of organisms are put under another small taxa phylum. Then from that phylum, based on some other similar common properties, emerge another taxa class. From that again size become more smaller and having and all are sharing more similar properties that forms the order, and from the order again those having very similar features forms the family, and from the family again precisely which all organisms are showing more similar characters, genus is forming, and from the genus again which all are having more similar characters, then and identifying giving it a species. So here is an example of wolf, coyote, and both are wolves, but the genus is same, but species is two. So that two means there exists some difference between these two. This is the lineage classification. Then llamas and Darwin's contributions also here. What they contributed? They told that species undergo gradual transformation and finally it leads to the evolution of new species. That's the opinion given by Lamarck and Darwin. Then we need to understand what are the modern trends in taxonomy. Various approaches are present. So many approaches. Many taxonomists are present and they are doing taxonomical works. They have their own way of approaches. Approaches means from among the various accepted methods, each taxonomist following their own convenient methods. Then we are going to see which are those approaches. Morphological approach. Some taxonomy always relies on this morphological. In this type of approach, how organisms are classifying by considering its morphological characters. And for understanding and distinguishing its morphological characters, main instrument using is scanning electron microscope. Then embryological approach is another approach. Here the taxonomists consider the changes in the pattern of characters during the development of organism. As the organism develops, its developmental stages, how that characters changing pattern, in what pattern its characters are changing, developing, by considering that means embryological aspects. They are classifying organisms. That's the embryological approach. Then ecological means ecology. Ecology is relating with habitat, breeding season, it's environment. So, considering all the data relating with the organism's habitat, its breeding, its other environmental factors, some taxonomists used to classify organisms. That is ecological approach. Then behavioral approach means some taxonomists consider organisms ethological character, means its behavior. Based on that characters they classify. The cytological approach means such type of taxonomy consider the cytological aspects, means some parameters, features like what's the morphology of chromosome, which is the size, what's the number. Based on that features, properties, some taxonomies used to classify organisms. There it is called a cytological approach. Okay, then so all these, even if all these so many approaches are present in the field of taxonomy, depends upon the convenience and interest. Every taxonomist can choose any of these approaches. Then some contrasting schools of taxonomy. schools of taxonomy means different fields, different systems, methods. Mainly three methods, three types of taxonomy is there: numerical taxonomy, evolutionary taxonomy, and cladistic taxonomy. We are going to see one by one. First, numerical taxonomy. Numerical, you listen to that term. Numerical means number related. How? What is numerical taxonomy? Here, the organisms are classified on the basis of what its morphology, means external appearance, and its genetic similarity. What is genetic constituents, and also morphology. By considering these two aspects, numerical taxonomists classify organisms. How they classify numerically? First, you just consider that two species are there, A and B. So, what the taxonomists first do? They pick out what all characters they can from these two species. First they write down all the characters, color, then it has flower, how many, if it is the case of animal, they can write fur is there, thumb is there, then color, skin color is this one. In that way, each and every minute characters pertaining to that two organisms, they looked up, and they are giving some numerical value for each character, and all that values should be have equal weightage. It's a table showing such a numerical coding of the characters. This 1, 2, 3, 4, 5 up to 10 indicates how many characters considered. This ABCD means each type of organisms considered. So, for example, we are first maybe some character. If it is person, that taxonomists give 1. If that character is absent, they are giving 0. That means you have that first character, second character, but seventh character is absent in the organism A. And he considers B also in the similar pattern. So, next intention is to understand how much extent A is relating to B. How we can understand that is an equation. Number of shared characters by total number of characters. By putting that value, means how we can calculate that number of shared characters. 1, here both have this character. So 1, again 1. So 1 plus 1, 2, 3, here is not same. So we can't count. Here also it's not same. Here same. 4, here same. Both have the same same with respect to that particular character, both show the same property. So we can consider this one also. 5, again 6, here 7. So 7 is the shared character, and total means 10. So 7 by 10 is equal to 0.7. 0.7 is its similarity coefficient between A and B. Okay, 0.7 means they are 70% similar. A is 70% similar to B, or otherwise B is 70% similar to A in that way. So based on that similarity, we can draw such a branching diagram. Okay, and that branching point indicates the percentage of relatedness between that branch tips. Okay, every point it is written here. 53, I think it's 53. 53% of resemblance between these two. 83 between these two. 53 again between these two branching points. So that is such type of diagram is called diagram. Numerical taxonomy, I think you understand. Next, and this numerical taxonomy is mainly used to classify microorganisms. Then evolutionary taxonomy. Evolutionary taxonomy, what is the main principle? They use evolution. Evolution means you are giving more stress on the ancestral data. So, here they use the paleontological fossil related data for classifying organisms. And also along with that they use the morphological resemblance. They consider the morphological resemblance, how the two species morphologically similar, and also phylogenetic. Phylogeny means how each organism relating with its ancestor. What method? They consider relatedness based on how recent it differs from its common ancestor. Because here again this is not a diagram. Let's consider the starting point of vertebrate. Vertebrate, how it emerged because of having a vertebral column, and from that so many emerge, and finally in the last number human beings. So considering how far that human from the common ancestor, it is too far. If we consider fish from that, it is more closer with that common ancestor. So in that way, the evolutionary taxonomy is classifying. Then cladistic, that cladism is found by Willie Henny in 1966. And what is clad? Clad means it's a biological group of species recently derived from a common ancestor. Means very recently. Here is the one common ancestor, and all the others very recently, nearby time evolved out of from this common ancestor. The group is called clad. They are called monophyletic group. Then cladistic means the classification system of classification based on clades. And this classification's underlying principle is they consider the relationship between ancestor and the descent. And cladogram is given here. It's a branching diagram depicting species divergence from a common ancestor. Okay, with this we can finish today's class. Thank you.